Okay, for this one, this is another rule for the exponents, and this is raising a power to a power. And this is really easy. If you have n to the m and you take it to the n power, all you do is n to the m times n. You just multiply the little numbers, basically. So on this one, what's the simplified form of n to the fourth to the seventh? Well, that's just n to the 4 times 7, so n to the 28th. This it applies to fractions too. So the second one, what's a simplified form of x to the 2/3 taken to the 1/2 power? Well, if you remember back when we did the basic skill stuff, that's just x to the 2/3 times 1/2. Well, then here you have mumbo jumbo, so it's x to the 1/3 power. Okay, see if you can do the got it for this problem number one. Look at this one, simplifying expression with powers. What is a simplified form of that? Okay, there's a lot going on here. So the first thing I'm going to do is, I see I got y to the third times y to the 5/2, and that's being taken to the -2. So I got to do, please excuse my dear Aunt Sally. So what I'm going to do with this is I'm going to take care of this first one, or excuse me, the second one. So this is y to the third times y to the -10/2, because that's negative 5 times -2 is -10/2. So now that becomes y to the third times y to the -5. And since these guys are the same base, I'm going to add them. 3 plus a -5 is y to the -2. So you could write it like that, or you could write it as 1 over y squared. Either one. I like the y to the -2, but other people like the other way. Okay, so try the got it for that one. Here's a problem number 3. Simplifying a product raised to a power. Multiple choice here. Which expression represents the area of the square? All right, so a square has all four sides. It's going to be this, right? So the area is going to be 5x cubed squared. Now this gets tricky because now this applies 5 squared x to the 3 times 2. So 5 squared is 25, and x to the 3 times 2 is x to the 6. So bubble on ND. All right, does that make sense? Not too difficult on that one. All right, another one. Simplifying expression with products. What's a simplified form of this? So there's a lot going on. So the first thing I see is this guy, n to the 1/2 times 10. So that's going to be n to the 10/2 times 4 to the third m to the third n to the -2/3 times 3. Now 10/2 makes 5, so that's n to the 5th. And then 4 times 4 times 4, so that's 16 times 4. And I left my calculator at home, so I'm just going to do this. 4, and then there's 64. So that's 64 m cubed. And then this is going to be n to the -6/3. If I repolish this up, I'm going to go 64 times m cubed times n to the 5th times n to the -2. Now the 5 and the -2 can become together, so 64 m cubed n to the third power, because 5 plus a -2 make 3. Easy enough, right? Here's one that's involving scientific notation. All right. The expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the third kilograms traveling at a speed of about 3.1 times 10 to the cube meters per second? Ugh, there's a lot going on. What I do see is this guy, and that guy, and then something about this. Okay, the expression 1/2 mv squared is the kinetic energy. All right, so I got to do kinetic energy. So I have 1/2 mv squared. Now 1/2 m is the mass. All right, so 1/2 the mass of 1.3 times 10 to the third, and then the v, which is the velocity. All right, it's traveling at 3.1 times 10 to the third, and they're going to square that. Now I'm going to show you what this, well actually I want to rewrite this. This is 1/2, and this is 1.3 times 10 to the third, and I guess that's kilograms. And then this is 3.1 times 10 to the third, and that's meters per second, and that's squared. All right. So the first thing I'm going to do is I'm going to leave the 1/2. No big deal. And I'm going to leave this 1.3 times 10 to the third kilograms. All right. But what I am going to do is I'm going to apply that squared to everything. So it's going to be 3.1 squared times 10 to the 3 times 2. And then that's going to be meters squared over seconds squared. And that's what velocity is, meters squared per second squared. All right. So then what I do have now is 1/2 times 1.3 times 10 to the third times 3.1 squared times 10 to the sixth, and I'm going to say meters squared second squared times kilograms. I'm just keeping my units off to the side there. Now what I'm going to do is I'm going to figure out, well, if I can bring this kind of make it together here. I'm going to go 1/2 times the 3.1 squared, which I'll figure out in a second, times the 1.3 times the 10 cubed times the 10 to the sixth, and this is meters squared kilograms per second squared, whatever that is, right? So what I can do now is I can figure out what 3.1 squared is. 3.1 squared, I believe, is 9.61. So this is 1/2 9.61 times 1.3 times 10 to the ninth. And this is your units, meters, kilograms per second squared. So 9.61 times 1.3 equals 12.49, and I divide that by 2, and I get 6.2, so it's 6.24 times 10 to the ninth meters squared kilograms per second squared. So that's the kinetic energy. So this unit right here, you're going sciencey on you, that is equal to a joule. Okay, whatever that is. I guess you'll learn that in physics or something. All right. So I hope that's easy. Try the got it problem. All right. So that's the end of this one. So make sure you know how to do all that, and check to see if you understand. And I look forward to seeing you in class, and may the force be with you.